Hey everyone, this is John Buck. Welcome back to another Discrete Time Linear Systems video. And in this video, I'm going to pick up the story of processing continuous time signals in discrete time and talk about the other end of the chain, the reconstruction or interpolation, before we fill in the middle with the filter. So we've already talked about sampling. There's two videos already on sampling and an example spectrum on this one, before this one, so make sure you pause and go back and watch those if you haven't already seen them, or this one won't make much sense. Okay, so let's pick up the story. Right, so our story so far, again, the big picture we're looking at today is we're going to start with a continuous time signal, sample it, filter it in discrete time, and then reconstruct it or interpolate it back to continuous time. And so far, the piece we focused on, right, the previous video covered this piece. So we've done that. The next thing we're going to do is this piece over here, the reconstruction part. They say when I have a discrete time signal, what happens when I go back to continuous time, particularly in the frequency domain? We'll see that. So let's go on and see how that works out. So again, the reconstruction filter, this is what is inside that box that says D to C. That wasn't the button I wanted. But all this is happening inside the box that says D to C on that original diagram. And so again, it's having T fed into it. And there's two real steps. You multiply the time axis by T to get back to the pulse train signal. And then we have what we call a reconstruction filter, a low-pass filter, to recover it. And when we do that, again, just labeling all these things in frequency, we start with a discrete time frequency, e to the j, y sub d of e to the j big omega. So at this point, we'll have back to a continuous time thing, y sub p of j omega. And then the final step after the filtering it will be the continuous time output, y c of j omega. Okay, and when we do this, there's really, not surprisingly, the first step is, say, if we're going to multiply the time axis by t, we're going to divide the frequency axis by t. There's really two steps here. So the first one says that if we multiply the time axis by t to get from n to continuous time, that's equivalent in the Fourier transform to divide the frequency axis by multiplying by t in time. I'm going to be dividing by capital T in frequency. So divide the frequency axis by capital T to convert the discrete time frequency big omega to little omega, the continuous time frequency. And then the second step, we're still going to have something periodic and we just want one copy. So the second step is this interpolation or reconstruction filter. And we'll see that we want to keep the things between minus pi over t and plus pi over t. And we need to imply a gain of t. To undo the 1 over t that happened earlier. So in continuous time, this is what we call the reconstruction filter. So H sub r for reconstruction of j omega. But it's basically a low-pass filter. Okay, so if we do that, let's go on. I'll keep the example right on this video. If we go to the next page. Let me skip past that for now. But remember we had this discrete time example with, let me draw it better. Right, so this is centered at 0 and it was up to 2 pi over 3 minus 2 pi over 3, and then it repeated itself, centered every 2 pi, like all well-behaved discrete time spectra are. So this was our input, but imagine now this is our output, and we're going to follow the steps through too. So imagine our filter hasn't changed anything, which is another good question you might want to stop the video and think about, of what what would be, or could come back to it later, what would be the discrete time filter that doesn't change anything here. So this is minus 4 pi over 3. This would be 4 pi over 3. So again, the first step, we multiply the time axis by t. We're dividing these. Again, our t was 1 over 300. So we're dividing each of these by 300. So when I do that, this is big omega, little omega would be big omega over t, which is 300 times, in this example, 300 times what I have. So this would be my yp of j omega. This would still be 300 tall. But now this point here is 300 times 2 pi over 3 will be 2 pi times 100 again, minus 2 pi times 100. And then another one of these, and this will be back to being at 2 pi times 300, and then a symmetric copy on the other side. So this is my periodic version back into continuous time. And then the last step, HR of t, says I need a filter that cuts off at pi over t, which would be 300 pi, or 2 pi times 150. Right, so my reconstruction filter, let me put that on the side just to make sure people follow it. My reconstruction filter is a filter that has a cutoff of pi over t and minus pi over t with gain of t. And this is the filter. We say it's a filter. Its main job is just to keep the center copy, to get rid of all the extra copies from the sampling. By interpolating in time, it's removing all these extra copies and just keeping the central copy. So here, 1 over t would be 300. So this is pi times 300. Or if I'd like to pull the 2 pi out front, it would be 2 pi times 150, and this gain would be 1 over 300. So this would be 1 over 300, and this cutoff edge here would be 2 pi times 150, which is right between it. So in between and everywhere else, this is 0. So at each frequency, it's just our usual filter. I multiply each frequency by the gain. So in between here, in the passband, everything, this was 300, gets multiplied by 1 over 300. And so what I'm left with, when this is done, is a reconstruction with a gain of 1, and then this is back to being my 2 pi times 100, so between plus or minus 100 hertz. Okay, so this is the interpolation or reconstruction part. I'm going to stop this video here before it gets too long, and then we're going to go on to a new video. We'll talk about the filtering part in the middle, what would actually happen, and then carry the whole thing through, realizing that this might be a little misleading because the filter is not going to let these go through unchanged, but it is what it is. This is where we're at. So we've talked about reconstruction. If we go back a couple pages, right, we've talked about step 1. Now we've just done this. We have finished this part here, step 2. And so I'm going to now talk about, well, what happens in the middle with the filters? Sort of doing them out of order, but these are the complicated ones. We've done this before. We've done filtering already, multiplying things through. But I'll pick that story up in the next video. So that's all for this video. I'll see you next time.